Yes, students, today I have solved you some problems of Fourier series. Yes, okay. Now the question is, find the Fourier series expansion. Yes, of for f of x. Yes, if fx is equal to minus pi, for minus pi is less than x is less than 0, and x for 0 is less than x is less than pi, and deduce that, yes, deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus up to so on is equal to pi square by 8. Yes, this is the question, yes, which we want to solve it. Okay, therefore Fourier series, you know all the terms for the Fourier series. So the solution is defined as, yes, solution of this question is defined as, yes, the Fourier series the Fourier series of f of x in minus pi and pi is, we know, yes, you know the Fourier series, f of x is equal to a naught, yes, plus sigma n varying from 1 to infinity, yes, an cos nx, yes, you know that this result, and plus sigma n varying from 1 to infinity bn, yes, sin nx. Yes, earlier video I have solved this and also proved this Fourier series. Okay, a0 here where the a0 and bn are defined as, yes, now we find out from this condition, we find out a0 an bn, substituting this, and then we find out the Fourier series. Okay, this is the process that in Fourier series, here you know a0 an bn are Fourier coefficients. Yes, so you find out a0 an and bn. Yes, and you know that where you know a0, yes, this one you know 1 by 2 pi minus pi to pi f of x dx. Yes, you do this one. Now from these conditions, yes, this can be written as, this a0 we have to find out this a0, this can be written as 1 by 2 pi, yes, here minus pi, from the definite integral property, you know that a to b f of x dx is a to c plus c to b. We are applying here, we are taking the interval in minus pi to 0 and then 0 to pi. Yes, okay, so this can be written as minus pi, yes, minus pi to 0 f of x, yes, f of x dx plus here is 0 to pi f of x dx. Yes, clear? Now what is the value of f of x? You see from here, f of x, this is equal to minus pi, and when the limit from 0 to pi, then this is x. Yes, clear? So we substituting here, and therefore you get this is equal to 1 by 2 pi, okay, and this one become minus pi to 0, and f of x is minus pi, okay, dx plus 0 to pi, and here f of x is x dx. Yes, clear? Now integrating this, and you can find out the value of this one. Okay, you get the value of this is equal to integrating here is pi minus of pi x, so taking the limit, and here is also x square by 2. Yes, so if you solve this integral, then you find the value of this one is equal to, yes, minus pi by 4. Okay, you can solve this. Okay, this integral you can evaluate. Now you find the a0 is this one is equal to this one. Yes, clear? Now you find what is bn. Yes, is an and bn. So an, yes, so an is equal to, yes, an is equal to 1 by pi, yes, minus pi to pi. Yes, you know this result, f of x cos nx dx. Yes, okay. Similarly, on the same process, you divide the integral in 0 minus pi to 0 and then 0 to pi. Yes, okay. So this can be written as 1 by pi, okay, and this can integral minus pi to pi. Yes, f of x. Yes, here the f of x is minus pi to 0, then 0 to pi, okay, minus pi, okay, f of x is cos nx dx, okay, plus 0 to pi, and here f of x is x cos nx dx. Yes, you have cleared it. F of x is in this range is minus pi, so you substitute here is minus pi, and in this range is x, so you substitute x. Okay, now integrating on the same way, we have also we want to show it this integral solution of this integral. Okay, then this is 1 by pi, okay, and this is become minus pi, and integrating this one, this is equal to sin nx, yes, by n, okay, and taking the limit from minus pi to 0, clear, plus here is two terms, x and also cos nx. Yes, you can also integrate in this term, okay, so this one x sin nx, yes, divided by n, yes, plus here you two times integrating, so you get this one is equal to plus cos nx divided by n square. Yes, and taking the limit at 0 to pi. So, okay, you have cleared it now. Okay, now the next one. Yes, and now we find evaluating the values, or evaluating this value you get, yes, this is equal to an you get, yes, here is an. So yes, so evaluating this you get 1 by, yes, 1 by pi, and also the taking the limit, that is you get here is 0 plus 1 by n square, yes, cos nx and pi, okay, minus 1 by n square. Okay, so solving this you get 1 by pi n square, and here is cos n pi minus 1. Yes, this is the value of an. On the same way, you can also find out the value of bn. Yes, okay, now for bn, you know the result of also bn, which is defined as 1 by pi minus pi to pi f of x, yes, sin nx dx. Now for the same process, you divide this integral from minus pi to 0 and then from 0 to pi. Yes, okay, now this becomes again, yes, 1 by pi, and here is this is minus pi to 0, and f of x in this range is in this range is minus pi, yes, minus pi, okay, and sin nx, yes, and sin nx dx plus, yes, the limit from 0 to pi, and here is function is x sin nx dx. Yes, okay. Now similarly, as you have solved the an, similarly you solve this bn. Yes, similarly solving this you get 1 by pi, yes, 1 by pi, and here is again pi, yes, and this is, you know that negative sign, so here is not, and n is also is here, okay. So pi cos nx divided by n, and limit from minus pi to 0, plus also this earlier an, similarly as the earlier you can solve this one. This is equal to minus of cos nx divided by n plus sin nx divided by n square, and taking the limit from 0 to pi. Okay, now I think you substituting these values, and now you get the values. This one is equal to 1 by, yes, here is 1 by, here is pi by n, so pi is cancelled out from on both. Okay, now you get the values here, similarly from here you get, so you get the values, you get this one is 1 by n, yes, 1 minus 2 cos n pi. Okay, so you get an, you get this, you get here is a0, an and bn, and now substituting here is again in this series a0, an and bn. Okay, substituting here in this Fourier series you get, yes, you get this fx, the Fourier series is, yes, therefore the required, okay, required Fourier series is okay, yes, Fourier series become f of x. Okay, now substituting a0, which is minus pi by 4. Now substituting this one, this is minus 2 by pi. Okay, and here is expanding from n is 1 to infinity. Yes, here your summation is, here is summation n from 1 to infinity. So expanding this one also n, yes, expanding this you get, here is, yes, you get this one is cos x, so not here we write because here is only one term, so cos x, you can say that, plus cos 3x divided by 3 square, yes, plus cos 5x divided by 5 square, plus up to so on. Similarly for bn, yes, which is plus 3, yes, sin x minus 2 sin, yes, minus 2 sin 2x, yes, divided by 2 plus 3 sin 3x divided by 3 minus, yes, similarly sin 4x, and now so on. Okay, this one, yes, clear? Here in this series, now for the deduction of this is actually this is the series, you get the solution of this Fourier series, but here in your question you also this one deduce that this one. So for this we use earlier, actually this is the Fourier series, yes. Now for this one, for this value, yes, deduction is now here deduced, because so deduction is now for the deduction, yes, yes, for deduction, yes, putting x is equal to 0, yes, in equation number, let us suppose that this equation is 1. because here this become the Fourier series. Okay. If x is equal to 1, then you get f of 0, this is equal to minus pi by 4 minus 2 by pi, yes, and here is 1 plus 1 by 3 square, yes, plus 1 by 5 square, plus up to infinity, because here if you substitute 0, then this term is cancelled out, so this one become only this one. Yeah. Now you have to find out the series of value of this. Okay, yes, so but f of x is discontinuous at, you also know the continuity of any function, so you can check it. Now you see here for the function f of x is discontinuous as x is equal to 0. So we have f of 0 minus 0 is equal to minus pi, and f of 0 plus 0, putting x is 0, so x is 0, then this is 0. Yes, because as here is x is 0, so this one is 0. So for the continuity, yes, f discontinuity, f of 0, this is equal to 1 by 2, yes, f of 0 minus 0, yes, right hand and left hand, and plus right hand, yes, plus f of 0 plus 0, and substituting these all the values, this is equal to 1 by 2 of 0 minus 0 and also 0 plus 0. So you get the value is minus pi by 2. F of 0 is this one. Okay, let us suppose that this equation is 3. Okay, now because you have deduction is this one, so now from equation 2 and yes, now from 2 and 3, yes, from 2 and 3, yes, from 2 and 3, using this one, we have minus pi by 2, which is equal to the series minus pi by 4 minus 2 by, yes, minus 2 by pi, and here is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus up to so. Or solving this equation, yes, we get 1 by 1 square plus 1 by 3 square plus 1 by 5 square. You get this is equal to pi square by 8, which is the solution of this equation. Actually, yes, here you deduce this one. Yes, okay, actually you get always you get the results if substituting x is 0, or you substituting the different type of the value according to the deduction. Yes, but for here, because of this discontinuity, you use this one for the f of 0, so substituting f of 0, and now also if f of 0 is, then this one equation. Yes, so from equation, yes, yes, this one is f of 0, yes, this equation is 2 actually. Yes, so using the equation number, yes, 2 and 3, f of 0 is here, yes, f of 0 is here, substituting, so computing this value, and now you get the value is this. Yes, students, I think you have cleared this problem. Now next example I have to find it different type of problem. Okay, students, thank you.